2/3 of the actual warming has happened during my lifetime, so this is something that's happening now and it's happening quickly, right? Today is, or yesterday, right? This week is probably a good time to be talking about this. There was obviously a huge heat wave that just swept across the world. Yesterday was the warmest it has ever been in recorded history in Paris. Also the warmest it's ever been in recorded history in London, right? So this is a problem that we need to deal with really quickly. And it's not even the most urgent or problematic ecological problem, right? So this is the planetary boundaries framework. There are 8 different categories of variables that we can measure about the natural world. We have defined boundaries, so a safe zone, an intermediate zone, and a danger zone for each of these variables. And global warming isn't even the variable that's farthest out of whack, right? So we're losing biodiversity massively quickly. There's a huge amount of biogeochemical flows, so phosphorus and nitrogen, which are mainly from agriculture. So we need to understand and track all of the ways in which we are interfering with the natural world and making our planet less sustainable, and we need to do it really, really quickly. So I'm gonna walk through these 5 different points here. So firstly, I'm gonna talk about sort of the texture of the problem, right, and sort of our philosophy of this problem. And we really think that Web 2 plus fiat is insufficient for solving these problems, or even sort of tracking and aligning incentives in order to solve ecological degradation. And then I'm gonna talk about what we're doing in Filecoin Green to build sustainability tools, so Web3 native sustainability tools for tracking these problems and aligning incentives. Then I'm gonna talk about this Web3 global sustainability ledger and what that could look like in the future. I'm gonna talk about why net zero is actually not enough. And then I'm gonna shill the Sustainable Blockchain Summit a bit, which is happening this Friday and Saturday, right after EthCC in Paris. So the economy is an information processing system. This is one of the few things that Marx and Hayek agree on, right? They ultimately both frame their points in terms of where information processing should happen, and they do this very explicitly in their writing, right? So the economy is an information processing system. Another place you see this is Coase's theory of the firm. Coase asked, why do companies exist? Why don't you just have individuals transacting in an economy? And the conclusion that he came to was that the boundary of the firm exists, this boundary between internal transactions and external transactions is ultimately about trust and presumption of alignment. And so between companies, you have simpler transactions. So you contract for a good or a service that is bounded both in time and in complexity, whereas within a firm, you have these things like employment contracts that are unbounded or much more complex. And you can do that because you have this presumption of alignment and presumption of trust, right? And so what that means ultimately is that centralization in highly centralized companies is an informational crutch, right? And so only price signal information can easily pass from firm to firm, whereas you can have these much more complicated relationships within a firm where you can pass things other than price signal information much more easily, right? And what's exciting about where we are right now is that despite the fact the extractive economy was built with this crutch sort of fundamentally in place and central to it, we now have the tools to build new types of organizations that can pass information other than price signals more efficiently between them. And so why is this relevant to environmentalism and sustainability? This is a schematic of the greenhouse gas protocol, which is the gold standard for assessing an organization's carbon emissions. And so the way this works in sort of a schematized or quick view is that you have a company, you want to understand its greenhouse gas accounting. So you look firstly at what the greenhouse gas protocol, the GHGP, calls scope 1 emissions. Those are direct emissions from burning fuel on site as part of your operations. You look at scope 2, which is emissions due to electricity. You look at scope 3, which is far more complicated than scope 1 and scope 2. That's all of your emissions due to your supply chain, so due to goods and services that you purchase. And the first thing you do is you try to reduce your emissions due to scopes 1 through 3. And that comes back to why net zero is not enough, which I'm gonna talk about a little bit at the end. But then what you do is you can use offsets and other tools to mitigate what you can't reduce, right? So try to reduce your more direct impacts first, then offset what you can't reduce. And then Then you can do your own internal carbon accounting. You get a check mark. You show that to your shareholders, your investors, and then you also are in a position to define what your downstream Scope 3 emissions look like, right? So this is the accounting exercise that we want to do ultimately for every organization, every company. But this is complicated, and it's hard to get right. You have to double check a lot of things. And so it takes auditors a long time to actually do this exercise, right? But we have to do it manually with the tools that we have now. If we use Web 2 and fiat, we have to do this manually. Takes a long time, takes external auditing firms months to make sure it's right. And so what are the implications if we think of the economy as an information processing system, and we want this type of information, the sustainability information, to be passed quickly from one company to another so we have accurate, timely information to make decisions? What are the implications of this, right? So company A goes through this exercise. Typically, they do this exercise, this auditing exercise, once a year. They then pass that information down their supply chain. The next company takes that information, uses it to determine its Scope 3 emissions, and then it takes a year to run through that auditing exercise itself. Then it provides that information to company C, it takes another year. So the IPCC is saying we need to decarbonize the entire world by 40% within 8 years. This single year for every hop along the supply chain is just not going to cut it, right? We need ways of transporting this type of information through the economy much, much more quickly. And so here's a great meme on this, that the entire carbon accounting system is held up by Excel without particularly good methods for doing version control or anything, right? So this is just auditors like emailing Excel sheets to each other, and that's how we figure this stuff out. And so we can do a better job. So I'm going to talk a little bit about our take on how we're building this within the Filecoin ecosystem and within Filecoin Green specifically. So Filecoin Green is our effort to make environmental accounting a Web3 superpower. There are two parts of this. So we're trying to make Filecoin itself verifiably sustainable, and we're trying to build Web3 native tools in order to solve this problem that I just scoped out. So how can we take this information and pass it from organization to organization in a verifiable way? So that we can move this information through the economy in minutes, not in months or years. So IPFS, right, is the content delivery network of Web3. So if you're into networking, that's similar to a company like Akamai in Web 2. So IPFS is what content addresses your data and then gets it where it needs to be quickly. Whereas Filecoin is for long-term storage, right? And it's a huge network. It's closing in on 10% of the data storage capacity of AWS. So it's big, it's growing quickly. It's getting close to 1% of all of the information in data centers in the world is on Filecoin. So it's a big network for long-term data storage. And so there are two places where Filecoin itself uses electricity. So in order to onboard data onto Filecoin, you have to seal that data. That sealing process sets up a series of zero-knowledge proofs that are going to allow you to prove as a storage provider that you continue to store a copy of that data over time. You then actually have to store that data over time, which is the other major component of energy use of Filecoin. And so what we want to do, if we want to be able to pass information from player to player in the value chain quickly and efficiently and verifiably, we really want some source of truth as to what the emissions and what the energy use is of storing your files, right? And so we can go to the Filecoin blockchain, we can see cryptographic proofs of how much data was onboarded, how quickly, and how much data every individual active storage provider, every node in the network, is storing over time. We can then translate that into an energy use profile. If you want some of these links, so these slides are at tinyurl.com/filecoin-green-ethcc. There's a ton of references here. You can look up the documentation about what I'm talking about. So we did a lot of research, talked to a bunch of storage providers, tried to understand what are the bounds on energy use given a certain profile for sealing and storage over time. Right, and so we're able to take those proofs on the Filecoin chain, translate them into energy use profiles, and then we have this energy use view for every active node in the Filecoin network. And so, as I said, Filecoin is closing in on 1% of all the data center storage capacity in the world. It uses, a bit less than that in terms of energy use. This isn't exactly an apples-to-apples comparison. What this means is that sealing energy is comparable to workloads run on typical, on data, right? So the energy to store data is comparable to the energy to store data outside of Filecoin. The energy to seal data is a little bit less than typical workloads run on data in a typical data center, right? But it's not massively energy inefficient, and you can get a lot more information on this. So then what else can we do with that? Rather than just looking at the energy use of Filecoin globally as a network, because we're able to see node by node how much energy is being used by each storage provider in the Filecoin network, we can then try to find their location based on their IP, and then we can look at how the energy use of the Filecoin network is interacting with local power grids. Right, so we don't just have this amorphous mass of energy use, we actually have a detailed, granular, verifiable view of what the energy use of Filecoin is, location by location. Then what can we do next? We can then act to try to mitigate the emissions from that energy use by connecting the network to renewable energy. So what we're able to do, say you have a solar farm, you want to supply this individual Filecoin storage provider, they're both connected to the same power grid. What the solar farm can do is mint what's called a renewable energy certificate that the storage provider can then buy in order to account for its energy use and then make these renewable energy claims, right? We didn't invent this system. We are plugging into existing renewable energy markets and doing this in this granular, verifiable, transparent way so that you're then able to go to the Filecoin.energy dashboard. You're able to see the energy use profile of an individual Filecoin storage provider, and then you're able to download the certificate, which doesn't just say they're using renewable energy, but it says how much energy did they purchase, where did they purchase it from, and you're able to map the storage provider storing your file to a specific solar or wind or hydro or biogas plant and see specifically where is the power being generated and from what source in order to store my files. And so this is the type of granular, verifiable, detailed information that we think we're now in the position, right, with Web3 native tools to provide to people. So we're not just looking at sort of overall what are the emissions, but we're looking at in this very detailed way, right, what specifically are your environmental impacts? How can you reduce them? How can you mitigate them? So we also, we're working a lot with storage providers in order to try to help them reduce their emissions and impacts and make substantive verifiable claims that go beyond just the proofs on the chain. And so if you're interested in this, you can go to filecoin-green.gitbook.io. This is the sort of source of information both for our developer tools for looking at the renewable energy for the renewable energy use and energy use overall for individual Filecoin nodes, and also things like if you're a storage provider, how do you become a more sustainable storage provider? So this is going in the direction, for example, of what Descent is doing in the Netherlands. They installed solar panels on their roof using a grant from the Filecoin Foundation. And what we're able to do is take the data corresponding to energy use measurements in their data center, able to take data from the inverter from their solar panels and make all of that data publicly verifiable and audited by a third party so that we're just able to see, okay, not even just based on these estimates from the blockchain, but based on actual audited measurements, how much energy are they using and what energy are they producing locally. Right, so you can actually see if you go to this URL down here, there's a dashboard where you can see for each of their miner IDs, what is the power use measurement from the PDUs that are actually monitoring their racks and their data center. You can then see what is the net energy use of the overall facility, so how much power are they pulling from the local power grid. And then you can see day by day what is their rooftop solar production and how much energy are they producing locally. Right, and so this is something we're very much scaling up and working with storage providers and building all of this whole dashboard and auditing process in a way that nodes on Filecoin, hopefully nodes on other networks too, can use this same process for making extremely substantive, granular claims about their sustainability practices. So what does this add up to, right? Where is this going? How do the pieces I just described that we're working on connect to that philosophy I just described about why we need Web3 native tools in order to solve sustainability globally? So clearly this is what we're doing in our use case, right? So this is a schematic of the Filecoin value chain. you have electricity, you have hardware, those go to individual Filecoin storage providers. They provide storage as a service to clients, and that's the value chain, right? Then maybe the clients provide other services to people. You could extend this. So we're building the tools to allow you to measure, no matter where you are in this value chain, measure what your environmental impacts are, and then pass that information on to the next step in that value chain. And what that means is that no matter where you are in the value chain, you have the information that you need to decide what products and services to buy in order to reduce your impact, right? So that's the goal, right? And so we're building this in a way where as much as possible, we want to build this in our use case, do a really good job making this verifiable, and then generalize it as much as we can to allow anyone who wants to do something similar to apply it to whatever their network is or beyond Web3 to their value chain. So, why is this necessary? Why is this fundamentally different? Why did I make that really strong claim about Web 2 plus fiat is actually not enough to solve sustainability? Well, so my claim is that fiat money is actually a computationally insufficient substrate for modeling environmental externalities. So like, what does that mean? Money knows how to add, right? You have one coin, you have two coins, you add them, they have two coins, right? Knows how to subtract, knows how to do a couple of other things. But this is fundamentally different, right? This is like computationally different from modeling environmental externalities, right? So say you have one plot of land, it has some value. You have another plot of land, it has some other monetary value. You put them together, and the value to the ecosystem is not the sum of the monetary value of each of those plots of land, right? And those plots of land may have very different carrying capacities for biodiversity. If they're contiguous with each other, that's a larger area for your ecosystem to thrive in, right? So the same area of land is much more valuable to the ecosystem if it's continuous than if it's broken up into a lot of different pieces. And so what this means is that environmental value can't be reduced to just a price signal. And in Web 2 plus fiat, you have this price signal that can be transferred easily between firms or between companies, but to get that other information, to get that environmental modeling information, there's no easy way to transfer it, right? And that's why you need auditors, and that's why it takes a year for every hop down your value chain, right? And so what we need to do is transform from the sustainability report 1-year cadence into a system in which we're able to make these models of individual companies or individual projects, and we're able to audit them maybe on a quarterly basis or on a yearly basis. But then once we've made those models, we can actually pass that information at the speed of transactions, not at the speed of manual auditors, right? And there's the reason we need Web3 to do this, right, is all of this, right? We need to take data, we need to content address it. If it's self-sovereign, we're able to ascribe changes to individual players in the system. We need public verifiability, like, for example, referencing the Filecoin blockchain for individual storage provider energy use, right? All that information is public. That allows you to put bounds on what the energy use should be for an individual storage provider. I haven't talked about zero knowledge, but that absolutely needs to be part of this, right? Allowing a company to prove to its customers that what it's telling them agrees with what it's telling everyone else. Right, so you can see how these tools actually do lead to a phase change in how we are going to be able to account for environmental externalities and pass that information through supply chains. So, we can rebuild the global carbon accounting system to transmit data in minutes, not in months. And again, the IPCC, the Intergovernmental Panel on Climate Change, says we need to decarbonize the entire world by about 40% in the next 8 years. In order to avoid the worst effects of climate change. If it takes a year for every hop in the value chain for that information to be current, we're just not going to get there. So I wanted to touch on why net zero is not enough. So this is I stole this from the title of this great book by Holly Jean Buck, who's a professor at the University of Buffalo. And she says, net zero is not enough because if you imagine a world in which we are net zero because we emit just as much as we do now, but we also pull carbon out of the atmosphere, that is a very different world from one in which we emit drastically less than we do now, and we also pull carbon out of the atmosphere, right? So when you are buying fossil fuel products, you are locking in this extractive ecosystem that has People talk about co-benefits to offsets, right? So that's when you're not just pulling carbon out of the atmosphere, but you're restoring the planet. The fossil fuel industry does the opposite, right? So we actually need to not just understand what our emissions are and get to net zero. We need to understand what our emissions are, reduce those emissions in order to not lock in this entire extractive industry that is not just causing climate change, but also causing environmental degradation. And we need to get to net zero by drastically reducing our emissions and then also offsetting what we can't reduce, right? And so we need all of these tools in order to build that whole ecosystem and that whole world. So the last thing I wanted to plug is please come to the Sustainable Blockchain Summit if you're interested in this. You can get more details at sbs.tech, Sustainable Blockchain Summit. It's going to be this Friday and Saturday. It's going to be a great time. If you want a discount on tickets there, you can use the code ETHCC. There's going to be most of the major players in this space there. So there's going to be Toucan, Klima, Flow Carbon, Regen Network, a ton of people in the space. Troy Cross is going to be there, who's a Bitcoin maxi. Alex DeVries from Digiconomist is going to be there, who's the opposite of a Bitcoin maxi. We're going to have some really good conversations about all of this. And the goal is to get people with a deep understanding of how to build these tools in the same room as people with a deep understanding of all of the work that's gone into things like the Greenhouse Gas Protocol and all of the legacy industries that have spun up in order to manage environmental assets, right? So the UN Framework Convention on Climate Change is going to be there. It's a supporter of both the hackathon that we just ran and a supporter of the summit itself, the Rocky Mountain Institute. Gold Standard, which is one of the major offset accreditation bodies, is going to be there. If you want to continue these conversations, please come to the Sustainable Blockchain Summit. We just had a great hackathon that I just mentioned in partnership with Chainlink, Hedera, and Fluence. There were, I think, 200 something, 250 or something participants in it, something like 80 projects. We had a really good time. Then here are different ways to connect with all of this. Again, you can get to these slides at tinyurl.com/filecoin-green-ethcc. If you want to, there are a ton of links in everything I just went through. If you want references to anything I talked about, my contact information, sign up for updates, and plug in. We'd be happy to talk to you. Thank you.
And if anyone has a question, we can do a 2-minute Q&A.
Henry.
Do you have any plans to have other ecosystems like adopt these tools? And I guess, are you trying to generalize the tooling so it doesn't just apply to the Filecoin ecosystem, but to mining more generally in the space?
Yeah, definitely. I mean, everything we're doing, we're trying to build in a way that's as modular as possible. This auditing process, right, is meant to be scalable so that if you want to make strong claims about a data center, you can, get APIs, and connect those endpoints with whatever monitoring tools you have, right? So like your PDUs on your individual data center racks, and then connect to those, and then have an auditor that's not us, right? It's a third-party auditor, or choose a different third-party auditor to go in and like audit your data, right? We're also working with a bunch of the players on CO2.storage, which is an initiative that we're starting to launch to sort of standardize how offset projects work with environmental data, right, and make sure everything is like content addressed, and make sure that you have access to all this data so you can determine what's a good offset, what's not a good offset. So we definitely are building tools with that in mind.
You had another question? Okay.
I'm curious, like when you use like ZK proofs or something to like prove that you use like certain amount of energy, like what prevents these people from just not putting that data on chain and like hiding it forever?
Yeah. So ZK proofs are not a substitute for auditing, period, right? Like you have to audit information at the boundaries of the system, and you have to audit models within the system. But then ZK proofs are what's going to allow you to make representations to offset companies, to other members of your supply chain, and not show them all of your books, right? But allow them to see that what you're telling them agrees with what you're telling everyone else, right? Which is like, especially if we're going to generalize these tools, right, to legacy industry. That's crucial because they don't want to tell everyone how much power they're using, right? If you run a factory, how much energy you're using is like directly tied to your margin, and you don't want competitors to know that. But you do want to be able to tell people, how much, what's the carbon intensity of my products, right? And so that's where zero knowledge comes in. And this is something we're working on. We haven't built this yet, but like that's what's going to allow you to let people know, prove that you're not lying, right? Prove that like carbon in equals carbon out, and you're not like stashing it somewhere.
Thank you, everyone.
Awesome, thanks.